All right, I think we're ready to go ahead and get started here. They found us in the hall, and I guess the previous talk finished up a few minutes early. So someone start the timer. Here's our presentation, SPA Single Packet Authentication. And we have 19 minutes of presentation and approximately a little less than 60 seconds of demo. Okay?
Assuming everything actually works.
You turn your mic.
I was told not to until you turn yours off.
Really? Oh, okay. Okay, this is who we are. And,
all right, yeah. It is on. Yes. All right, good enough for me. I'm Mad Hat Unspecific, member of NMRC. My day job is manager of Vernier Threat Labs for Vernier Networks. That's about it.
And I'm a simple nomad, also at the NMRC, and I work at the BindView Corporation. And we both really, this whole talk came out of we're also involved with familiar with the DC groups, kind of the offshoot of from DEF CON, where you have like local meetings similar to the 2600 meetings. Okay, well anyway, we have one in our area, DC 214, and this whole presentation came up as a discussion over a lot of liquor as to whether you could actually send a single packet in and authenticate to another machine. So it's kind of where it came from.
All right, so first we're going to talk about what this is, the idea behind it. Once again, SPA, single packet authentication. The idea is you have a single packet that gets sent, and based on that packet, we do authentication. There's actually nothing listening on the box itself, so you don't have any open ports for this. I mean, of course, you can have open ports, but for this particular thing, there's not anything specifically listening. As the packets come in, we're able to do whatever we need to do. What it is not a replacement for authentication. It's another layer. It's another way of doing things. It is not specifically a replacement for port knocking, though it can be used for that, but it can be used for pretty much anything you want it to be. And it is not protection from attackers, but it can help because there's not something specifically, there's not an open port. So the design goals were that it's free, always a good thing. That we have, the payload is encrypted and signed. The idea is that it's fairly painless for the end user to use, to be able to get done what they want to do. That it would work across NAT, and I'll go into more detail about that here in a little bit. And then we can use TCP, UDP, or ICMP, actually. You could use other things as well if you really wanted to.
Okay. We had to divide up the slides because that's kind of in the rules when you do two people in a joint talk. So anyway,
tag team speaking.
Tag team. Anyway, the way this thing works is on the client side, client has a server's PGP key, GPG key, their public key on its ring. And what they do is they build the data chunk, and it includes some information about identity, session keys, timestamp, etc. And also command and control data for whatever application is using SPA. It encrypts it, signs it with the server's key, and then it sends that as a data portion of a packet over the wire toward the server. Now on the server side, the server has the client's GPG public key on their ring. They've signed it because you've gone through that whole signing thing and everything, so you trust this individual. And then it sniffs all these packets that are coming in, and it looks for those with its GPG key in the data portion. And when you encrypt something and don't do just do a normal encrypt and don't do the ARMOR encryption, the GPG ID appears like at offset 8 within the blob that you get out of that. So we just simply look for the private key, the key that's going to be able to undo the encryption. Once we find that, we grab it, we decrypt, and then we go ahead and do a signature. When we verify the signature, that right there says this is who I think that it actually is. We verify the timestamp, mainly to prevent replays. We have session keys to kind of try to keep things more or less in sync. I'll talk about that a little bit more in a minute, some of the problems with that. And then whatever the command and control then, and this is stuff that's been authorized in there, we go ahead and allow that to come through. And this is basically a more or less visual representation of what we're talking about, where you have the client on one end with its ID, and you have your server on the other end, and you can see that we can send the packet across TCP, UDP, or ICMP, and it's encrypted for the server with all the information inside there in this glorious graphical representation of said concept. Now you jump back over and cover this.
So really, this was just an idea of whether or not we could do this. But of course, if we stand up here and tell you, hey, this is a really great idea of how you can do this, and we can't say that we've actually implemented it, it kind of sucks. So what we're going to talk about now is our particular implementation of this. It's not specifically the only way it can be done. I mean, because different people can use this in different ways. So the challenges that we were trying to address whenever we were looking at this, and of course how we also addressed them, was in the instance of doing something like a port knocking type solution, there's a couple different issues. One of them was NAT. So we wanted to be able to make sure that if we were using this for that particular purpose, we could work with NAT. Or if we wanted to, we could actually just use it for straight firewall administration. In this particular case, we can specify a port and an IP that we want to open the firewall to, and then watch the traffic that's going across, and after a certain amount of timeout where there's no traffic, we can close the port. And if we don't specify an IP, we can just say use the source IP of wherever the packet came from. So, as far as replay, so whenever we first started talking about all this, what originally got us onto the idea, of course, was port knocking and things such as that. And one of the big issues is, well, if you just replay the same thing from anywhere, it's not a big deal. If you have a particular sequence that you're rotating through, you can replay it. So we had a couple different ways of being able to address that. The first one is, a simple timestamp. Just being able to say you only have a certain window where you can use that particular packet. The second way to try to keep from being replays is actually using sequence numbers. So the server knows a sequence number and the client knows a sequence number. And so whenever it decrypts, it checks the timestamp and the sequence number, and as long as both of them match, then it updates with the new sequence number that was randomly generated by the client before it does whatever it's supposed to do. Now, one of the issues we had with that is, well, what happens if the client gets out of sync with the server? Because there is no feedback from the server to the client doesn't know if it was successful or not. It basically sends it off, and then the end user does whatever they're trying to do. But if for some reason it didn't work, what we ended up doing is having a sliding window. In this particular case, we have two sequence numbers on each end, and as long as one of those match, then we go ahead and update. So it's, you have primary and secondary sequence number on each side. As long as one of them match to one of the two that the server has, then it allows it through. It does open up a slight issue, but in this particular case of our example here, port access, which we already mentioned, basically kind of like port knocking. You can open up any particular port for a particular IP, or if it's an unknown IP. Remote administration, we have implemented to where you can run pretty much any command. Now, the commands that you're allowed to run, we do have in the config file to where you can specify user X is only allowed to run commands A, B, and C, and nothing else. So, it's controlled a little bit. And then one that we don't have implemented at this time, but we like the idea and are going to try to implement it soon, is the reverse shell. So basically, you send the packet, it authenticates and everything, and then it creates a shell back to you. Everybody knows what a remote shell is. So, yeah, so what we have implemented so far is remote firewall administration, which works with IP chains, IP tables, and IPFW on FreeBSD. Expanding it to OpenBSD or other things is fairly trivial. And I'll let you go over this part.
Okay. This is roughly how the code looks. Obviously, the clients are on the left-hand side, and these are we're running Perl for just a simple client implementation, so it's a command line. It obviously could be done as a GUI. If you're interested in writing the GUI because it's that exciting for you, feel free to go right ahead and let us know about it. The main thing that listens on the server side is the SPA-D, which is the SPA daemon, and it is simply sniffing in promiscuous mode, looking for stuff. It doesn't need an open port or anything. In fact, the whole thing of this is you can have all closed ports. Once it gets what information it deems it needs to pass on to be acted upon, it'll pass it on to the SPA engine, which is running in Perl. It will go ahead and talk to GPG to decrypt as needed. Also, it'll check the user configs, and if it's doing the firewall stuff, it'll update the state of the firewall as it knows it. So that way, in case things have been rebooted, it'll at least maintain state, so to speak. And some of the, this it kind of helps, like, because some of the timeout issues we have, we couldn't basically just like look for a fin or something and say, okay, we got a fin on this, so now we need to close it down. Well, what if you're doing something like POP-S or something like that, to where it's going to be coming in, there's going to be a fin, it's because it's coming in every 5 minutes, right? Because you're checking your email every 5 minutes. Obviously, if you set your timeout for 15 minutes, you want to make sure that it doesn't just look at a fin and say, okay, I think they're done. I saw a fin, so you kind of put that in there. And, before we get to that slide, what I want to do is go ahead and actually attempt the demo. Man, I should have put this in here before I started it. Well, here's what I'll do. Everything's going to syslog.
So basically what we have on here is 2 VMware images. One of them, the names were things he already had set up for testing. So one of them is FC3 patched, and this particular box is where the SPA daemon is running. You can see here in the syslog messages where we have slight debugging turned on so you can see what's going on. But it says it's reading in the information.
Huh? Oh, geez. No, I don't have a way to switch the contrast. That's pretty bad, isn't it? Try resizing it a little bit. Does that line it up any better? All right, well, okay, I'll point out the important lines, okay?
You can highlight it.
Yeah, I'll do that here in a second. I'll show what's going on. Anyway, okay, on this side, certainly I have, okay, where was my, I have my whole key line in here already. As you can see, we were playing with this a lot. Okay, all right. Okay, so what I'm doing here on this command line, I'm telling SPA client that I'm going to, there's several parameters on here that you could do, like you'd say, I'm going to open port, I'm going to exec or whatever. Here, I'll highlight the line. Maybe this will be easier. Let's see. Can you see that a little better? Okay. Well, here, I'll just do this. So, okay, so that's basically what we're doing right there, okay? Fairly simple. And then over on this other screen, that's what we're doing. The communication that goes off between the SPA daemon and SPA engine is using a FIFO. And so you can see that we launched SPA daemon, it kicked off the SPA engine, everything got loaded up, we know what we're looking for and everything. So we go back over here and we have this thing set up so that oh, that's right, yeah.
Because we are using GPG, of course, you have to sign the payload.
Okay, so the packet's been sent. We go over here, and here, I'll get it highlighted. Let me see, we'll go all the way up here, and we'll get all this. And you can see up there at the top, it received the packet, sending the SPA payload, the SPA daemon sending over the FIFO. It gets all this stuff. It says this looks encrypted, so it goes ahead and decrypts it. It decrypts the data. Right now, since we're running in a debug mode, we're at least seeing what it decrypted. So it's showing us that the timestamp there on the line there, it says decoded. So I got the timestamp, the sequence numbers that it had in there, as well as what it's going to be doing, which is going to be running this program /root/test program. goes ahead and runs that. Looks like we got an error
Oh, sorry.
on something there writing the config. And then, but the thing is the test program, all it does is just put a message into syslog, which just says the test program for SPA was run. Okay, so and essentially we've implemented the thing there. So that's our big, and this, believe it or not, I had a VM image crash, and I spent like hours and hours last night and this morning getting this ready for approximately, well, just for tailing a log file. Okay, but it's just like damn it, I'm going to make this shit work. So had to do it that way. Anyway, that's pretty much it for our Turbo Talk. I think we're still got like maybe we've got about 5 minutes left. 3 minutes left. Oh man, we could have dragged it on forever. I wanted to get a shout out to some of the people that helped us on this. Druid, he's a guy all in green, right there. Raise your hand, Druid. He actually helped with some code and stuff and everything. So he was, and he's part of the DC214. He gave a lot of feedback. John Callis, I don't think he's in here. He's around the conference. His idea was because I was talking to him about PGP and stuff, and he suggested a dial-back VPN. He thought that would be a good idea to implement. And that was the last thing we were going to try to get done. Of course, believe it or not, that girl that's on the screen there is not anyone in NMRC's wives or girlfriends. It's a model we hired specifically for making slides. I have a very, very patient wife who'd allowed me to go ahead and pay a model and a photographer to take a bunch of pictures.
Yeah, that's a loving wife.
Yeah, it is. And so, and a lot of it's for DEF CON too, so we're going to be doing a big thing over at DEF CON. So if you're around for DEF CON, check us out on Friday at 3 p.m., I believe is what time our panel talk is, where we'll again go through this, but we'll also cover some other tools that we're releasing at the same time that we think are pretty cool and neat. And then we'll be doing some really fun and exciting things on stage as well that'll be offensive, and hopefully we'll go down in DEF CON lore. And that's pretty much it. So if anyone has any questions over the next 60 seconds or so, feel free to ask said questions. Problem? Yes. Yeah, we're Pardon?
I mean, a lot of companies have policies, you cannot have a promiscuous interface.
Yes, that's true. A lot of companies will not let you run this kind of stuff, and fortunately or unfortunately, the fact that it's open source may actually create a barrier from actually running it in a company. I mean, the code we have, like I said, this is mainly proof of concept. So, and we don't claim to be programmers at all. Okay, we're hacker guys that just to make a point, we had to code something up, and so that's. We're hoping that some programmer types will...
We're much better at breaking it than we are at writing it.
Yeah. Just to give you an idea, when I was writing the SPA daemon and I was testing it, I discovered that I'd coded in a remotely exploitable heap overflow. So...
That's been fixed, by the way.
That's been fixed.
As far as we know.
Yes, as far as we know, I seem to have corrected that particular problem. Oh, and as for getting the code... we've got portions that we're going to put up because we're still coding on it, I think, as late as this morning. So, but we will have the code up at that web address right there. And if you have questions or want to offer help or code, then we've got an email address down there at the bottom as well and everything. And we'll have a copy of this presentation up there as well. So, any other questions? All right, cool.
Thank you.
Lunchtime.